Oh, all right. Oh, so many titles. I thought about sort of the way to talk about pets today, and also sort of the topic, which sounded like ML was also sort of one of the issues covered. But recently, I've been on a lot of panels and other conversations, especially with people from legal, talking about pets. And this is actually something that often happens in the preparatory conversations when you're preparing something with people from legal, where you talk for a while and everyone looks confused, and then you realize that you're not talking about the same thing. And that privacy and pets are not the same thing. I come from a sort of privacy-enhancing technologies cryptography background, and I'll admit, even 5 years ago, it was a very naive view. People who worked on multi-party computation, all those homomorphic encryption, were like, oh, you can just solve everything, just do everything under encryption, and all problems are solved, and this is great. And ad tech can continue doing what it's doing while sort of improving privacy for users, but the thing is, from a legal perspective, and I generally agree with this viewpoint now, if you have encrypted data to which you don't have the key and that you cannot decrypt, but you can still, like in this diagram, cause an event to occur that affects an individual person by taking that encrypted data and still taking an action with it, like giving it to someone else who can then cause a targeted ad to be displayed to you on your device, that data is not de-identified from a legal perspective. And that kind of forces you to look at a more nuanced, in a more nuanced way at what is the value of privacy-enhancing technologies then at this point? Where is it actually sort of benefiting anyone to even introduce them into these flows? And one way to think about that is, the way that regulations and some of the big players are moving is they want to take the consent that users have to grant when they interact with systems, and they want to scope it down to narrow that consent to something smaller and smaller. The players that are best positioned to do this in terms of making the consent they request from users match what they do are actually the people who are closest to the device and the browser that the person's using. So the browser developers, the device manufacturers, they actually have the most kind of almost monopoly on this. And so they have the leverage, as we all know, in the industry because of that. Second, the first-party data owners, to a certain extent, have more leverage as well. But the entire ecosystem in between, DMPs, SSPs, DSPs, everybody, the only kind of consent we used to be able to ask for is everything. Like, can we do everything that we can possibly do with your data? Because and now with ML, it's even more, right? Now at this point with ML techniques, we can do even more with everybody's data, all the way up to and including making a model of the person pretty much. So what these technologies do allow us to do as we build out this intermediate ecosystem is they allow us to actually continue to scope down just like everybody else is, kind of evens the playing field, right? We can also, as an SSP or a DSP, we can ask users to consent to less. If all I can do is cause a targeted ad to appear on your screen, but I can't resell your data to 20 vendors because of the technology stack that I've chosen and what I've built, then that allows me to ask for less consent. And that might fit the spirit of the times in terms of regulations, in terms of what the big influential players are doing. So now we're going to get into the kind of more of the pet zoo part of the talk here. But one dimension to kind of separate out these pets into, and I should clarify that the pets that I'm talking about are cryptographic ones for the most part. So I usually refer, if I talk about pets, to the cryptographically rigorous ones. So things like anonymity, as well as things just like not sharing the data, which is actually part of the solution stack for things like Privacy Sandbox. They actually just don't share some of the data that they used to, right? You could argue those are pets too, in a way, but because they certainly enhance privacy. But for the purposes of this talk, I usually talk about cryptographic techniques. And for the cryptographic techniques, there's basically two categories that you could separate them into. There's input privacy and output privacy. And that also affects what kind of consent you might ask users for. So input privacy means, and I kind of drew this picture here, what does that really mean? It means if you have the raw data and you want to convert it in a way that when you deliver it, you will have this property of input privacy, is you basically have to have the data not have any information when you deliver it. Encryption does this. If the recipient doesn't have the decryption key and you deliver encrypted data to the recipient, that is input privacy. They do not see the inputs, and they may still be able to add value to the data. Like I said before, they could forward the data to someone else who can decrypt it and then show a targeted ad. But privacy-enhancing technologies, as some of us I'm sure are familiar with, they allow you to do any computation over that data as well, which could do things like matching and so on, and that's what some of the solutions we'll see in a moment do. And then there's output privacy, of which the only cryptographically rigorous one is differential privacy. So that basically is it's in its own category here, but that one basically shifts the data around or adds noise in some way. So that's sort of in its own category. All of these technologies have various architectures if you actually deploy them. So you'll notice that the differential privacy one is the simplest one to deploy as a workflow because you can do it unilaterally. You can just, if you have data and you want to share a differentially private version of it, you can just do that on your own. You don't need anybody else's participation or cooperation to do that. And you get this output privacy property where you reduce the utility of the data, but you do increase potentially, what you can do with that data relative to the consent that you requested from the users, right? Because basically, differentially private data, when you publish it, ensures that no individual can be determined whether they're in the data set or not in the data set that produced that report, the differentially private report. For all the other ones, you need multiple parties for it to make any sense. You need multiple parties to provide, there needs to be someone who's providing a service and they're using that input private, encrypted input to do something with it. There's going to be somebody who's receiving it, because if there's any business value to be had from data that looks like the top part here, it needs to be that there's somebody else involved who's receiving something of business value or taking some kind of action with it beyond the person who sees that flat, random distribution. So I'm not going to get into these details, but happy to, in the Q&A, to talk about any of these, or any questions anyone has about the architectural kind of limitations and constraints associated with each of these. But let's get into sort of more how they're used in some of the solutions out there. So here I've separated it out into kind of activation and measurement attribution as the two major categories where there are currently proposed sort of widely worked on and publicized I don't know if any of these can be argued to be production deployed. We're almost there, but close to production in some of these cases. And basically, on the activation side, two of the major ones. Again, this isn't meant to be an exhaustive list, but probably at least half of the exhaustive list. You might have heard of Google Pair, as well as something IB Tech Lab has worked on, OPJA. Both of these use an MPC technique called PSI to do basically the matching step, where if a publisher and an advertiser both have PII, and you want to identify an audience that's in common that you can then use further down the chain, basically both of those standards use that PSI technique, that MPC input privacy technique. On the right side, we have a whole bunch of different measurement and attribution. I would say there's a lot more work in integrating pets into these workflows. And a lot of these use a combination of techniques. So for example, the interoperable private attribution solution stack, it uses MPC to aggregate data. And then it uses differential privacy to actually publish results, to get, for example, what your performance of your campaigns is, for example. And the differential privacy computation is being done on encrypted data. So you actually implement the differential privacy algorithm, which, remember, you could just do on your own if you just have a calculator or a spreadsheet. You could implement it yourself in the clear data. But that algorithm is rewritten using a language for MPC computations. And that is then run on data that's completely, going back to this picture. The input is completely informationless to the people who are actually running that algorithm to produce that report. WFA Halo is another pretty mature effort. I only learned about it recently, but they've got 30 advertisers. They've got some DSPs involved, and they're doing their beta this year. So they're doing, I think, five advertisers or DSPs are involved with real data now, and they're going to be actually measuring campaigns using MPC. So that's an effort. On the kind of the major big players, sort of Google and Apple side, usually their solution stacks, as I mentioned, they include a lot of only on browser or only on device stuff that happens locally, and then they take that and usually apply either differential privacy to it and share it, and or right now, recently, for example, even in Privacy Sandbox, they recently introduced trusted execution environments, which is also input privacy, but you need to trust the hardware manufacturers not to leak their keys. It's a little easier to use from a software engineering perspective, but you still have to trust the hardware. And I'll probably just stop on this slide, but A lot of these, especially the OPJA one, but others as well, are actually efforts being undertaken at IAB Tech Lab. So if you join these groups, as some of you are already sort of participating, you can start to join the discussion and see how the sausage gets made here, which is pretty involved, and there's a lot of trade-offs and difficult things to work through with all of the players with their different incentives present in the room when you're developing these. But we're working on it. We're working now on also one for measurement as well. So if you want to join that right now as it's happening, that's something that I would encourage you to do. And yeah, we're hoping to sort of present open versions of some of these. So that there's a counterpoint if some of these proprietary technologies and solution stacks are making certain choices. Having explored them at IAB Tech Lab, we can better assess what choices the big players have made when they develop these, and maybe even make arguments for or against certain choices based on our own experience coming up with these standards. And that's what I found most valuable about these exercises. But yeah, I'll stop there, and yeah, feel free to ask about this or talk after about any of these.
I had a question.
Yep.
Are there any updates from the Tech Lab that you can share with everyone that might not be public yet or announced yet?
I don't think I can, but I'm sure there are such things. I'm sure there were no hints in the slides about that. So, but I think that should happen very, very soon. So I think, yeah.
Cool. Any questions?
I just have a quick question. The WFA Halo effort, I wasn't familiar with that either. Like, what data, is data coming from publishers, or is this advertiser data that they're trying to sell to themselves?
So it's mostly advertisers, a lot of them in Europe, but all the big ones like PepsiCo and I think things like P&G are there and so on. So all of these efforts, by the way, that I showed pictures of. So there's champions within the organizations that are highly involved, but it doesn't mean that the whole organization is on board. Nevertheless, I would say out of everything I've seen, WFA Halo is probably the most mature. And again, I'm surprised. I mean, they presented at IAB Tech Lab over the last few years here and there, but I didn't really pay attention to it that much. But I attended one of their events recently. So it's mostly advertisers. They are building out essentially a virtual person graph, and I think it's mostly UK initially. So it's essentially a virtual model of 60 million people, and that model is being built via MPC. And then as far as I understand, what's going to happen is the actual data from campaigns is going to be mapped onto that virtual persons model, and that virtual persons model is going to be what the performance metrics are derived from, and then sent out to the advertisers, and I mean, and the publishers in a different granularity. So I don't know if that answers the question. I'm actually not super. They don't have a lot of materials publicly available about the technical details of what they're building. But a lot of, I think Meta and Google engineering teams are involved in building out the actual detailed, on the ground technology components. Great, thank you.
All right, thank you. Okay.